Hi guys, this is Steph. I had problem number 2 on homework 10, and it said prove that all the automorphisms of G is a group. So to prove it's a group, I have to show 4 things. That it's associative, it's closed, it contains the identity, and it contains inverses. So we'll start with associative. So automorphisms of G is associative because function composition is dissociative. So we just did this. Oops. So number 2 is closed. So to prove it's closed, first you're going to assume alpha and beta are members of automorphisms of G, which implies that both alpha and beta by themselves are isomorphisms, so each one is operation preserving. So if I want alpha and so the composition of alpha and beta of xy. So we could write that as alpha of beta of xy. So we know that beta itself is operation preserving. So I can turn beta of xy into beta x, beta y. We also know that alpha itself is operation preserving. So alpha of beta x, beta y is the same thing as alpha of beta x, alpha of beta y. And we can rewrite this composition as the composition of alpha and beta of x times the composition of alpha and beta of y. So we just showed that the composition of alpha and beta is also operation preserving because this equals this. So since the composition of alpha and beta is operation preserving, that tells us that automorphisms of G is closed. So we proved number 2. Next, we're going to prove the identity. So let IG be the identity map on G. So that just means it's the isomorphism that maps every element of G onto itself. So I sub G is clearly one-to-one and onto, as well as operation preserving, since nothing changes. You're mapping everything to itself. So I sub G is the identity element in automorphisms of G. Therefore, automorphisms of G has the identity. So, excuse me, we proved the third thing. Last thing we need to prove is inverses. So we'll go back down here. So let gamma be a member of automorphisms of G. Sorry, not feeling so hot. So this implies that gamma is an isomorphism from G to G. And if alpha is an isomorphism from G to G, that means that gamma, the gamma inverse is an isomorphism from G to G by homework problem 9.4. So that implies that gamma inverse is a member of automorphism of G. So therefore, the automorphism of G has inverses. So we proved all 4 things we needed to prove. So now we know that automorphisms of G is a group. And that's it. See you guys in class.